Today's lesson is on special right triangles from geometry, the 45, 45, 90, and 30, 60, 90 triangles. All right, so what is my learning objective for today? Today I can solve for sides of special right triangles by applying proportional relationships. And the key concept here is that all triangles with congruent corresponding angles have proportional sides. So all 45, 45, 90 special right triangles are proportional to each other, and all 30, 60, 90 special right triangles are proportional to each other. So what does proportional mean? So casually in middle school, we said that it is the same size and a different shape. In high school, we classify it a little bit more. We say that the corresponding angles are congruent and the corresponding sides are proportional. Which means I have equivalent fractions. Okay, specifically, we have some relationships of what the side ratios are, and we are going to first work out where they come from, and then we'll come in and fill in the table here from the front. Okay, so let's see, where do the numbers come from? Because I don't actually memorize them, I just know where they come from, so when I don't work with it for a while, I can generate the ratios. I don't have the numbers always memorized. Okay, so just to go with more academic vocabulary, since I have two equal angles, that means I also have two equal legs, so that a 45, 45, 90 triangle is classified as an isosceles right triangle. All right, so let's figure out the side ratios. So to find the side ratios, they actually come from a square. So if I have a square and I draw in the diagonal, and let's start out with and say our square has sides of 2. So in my table here, I have a leg of 2 and a leg of 2. So I know I have a square, so all 4 sides are equal. So if I said this was a leg of 2, I would want to know these are my 45-degree angles. And I'm going to be applying the Pythagorean theorem, so I want to know what the diagonal is, or the hypotenuse. So I would say this is a squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. So I have 2 squared plus 2 squared equals c squared. So 4 plus 4 is c squared. So 8 equals c squared. I want to know what c is, so I'm going to take the inverse of squaring, which is the square root. So I want to factor out a perfect square. So I know 8 is 4 times 2. So I want a perfect square. 4 is a perfect square. So when I take this out, this is 2 times the square root of 2 equals c. So if I do a square with 4, I find out this is 4 times the square root of 2. If I have any side x, it is x times the square root of 2. So in geometry, what I teach is I make a table. So I say these ratios are 1 1 and the square root of 2. And then I am putting in whatever the triangle information is here in these values. So these are the actual values from the triangle. So I set up my equivalent fractions, and I used 2 of the 3. And we'll get to that in a minute here. So let's do the same thing. So let's solve a problem here. How do we do that? Solve for x and then rationalize the denominator if necessary. So why do I need to rationalize the denominator? Well, when we solve for an answer in math, we want to compare our answer at the same stage. And mathematicians agreed that would be, I would have no radicals in the denominator. So if I have a radical in the denominator, they're rationalizing it. So other answers are equivalent, but when we're comparing, we just want to compare at the same stage. Okay, so what I teach in geometry is I see that I have a 45, 45, 90 triangle. So I have my students write 45, 45, 90. And I said the ratios are 1, 1, and the square root of 2. And then I have my students put what's actually in the triangle. So in the triangle, my two 45-degree sides are x. And across from the 90 degrees is 8. So these are equivalent fractions. So to solve for x, I just need to set up 2 of the 3. So I'm going to use these 2 of the 3, and solve for x. So I'm going to just cross multiply. So I have x times the square root of 2 equals 8 times 1. So I want to divide by the square root of 2. So now I want to rationalize the denominator. So to rationalize the denominator, I'm going to multiply by 1. And 1 looks like anything divided by itself. So I'm looking at what does the denominator look like. So the denominator is the square root of 2. So I'm going to multiply times the square root of 2 over the square root of 2, which is 1. So now I have x equals 8 times the square root of 2. And the square root of 2 times the square root of 2 is 2. I'm going to simplify, and I get x equals 4 times the square root of 2. So just a couple radical formulas that we just went through in the previous unit. So the square root of x times the square root of x is 1. And the square root of x times the square root of x equals x. So just keep these in mind because we'll work with these quite a bit. Okay, so now we know that the ratios for a 45, 45, 90 triangle come from a square. So where do the ratios from a 30, 60, 90 triangle come from? So a 30, 60, 90 triangle is classified as an acute right triangle. And I have 2 legs. The one across from 30 is called the short leg. The one across from 60 is called the long leg. And the side across from the hypotenuse, or side across from the 90 degrees, is called the hypotenuse. Okay, so where do these ratios come from? These ratios come from an equilateral triangle. So I'm going to set up, I know when I have an equilateral triangle, all 3 sides are equal. So let's say my sides are 2. So if I'm drawing in the altitude here, I'm dividing this side equally in half. Since it's an equilateral triangle, I know these angles are 60 degrees. And when I divide this side in half, I also divide this angle in half. So these are 30 degrees and 30 degrees for a total of 60. So I'm going to just work with one side now. So I'm going to maybe work with this side here. So I know one side, which is called the short leg because it's across from 30. I do not know the long leg. It is across from 60. And I know the hypotenuse is 2. So I'm going to use the Pythagorean theorem again. So I'm going to call the short leg 1, the long leg b, and the hypotenuse is 2. So I'm going to use the Pythagorean theorem again. So a squared plus b squared equals c squared. So we have 1 squared plus b squared equals 2 squared. So 1 plus b squared equals 4. I'm going to subtract 1 from both sides, so b squared equals 3. And then I want to take the square root of both sides. So I get b equals the square root of 3. So my ratios, we saw a is 1, b is the square root of 3, and c is 2. So sometimes we see this in charts as x times the square root of 3, and 2x. So I teach my students to work with the top numbers. Let's go fill in our chart here. So I teach my students to set up their equivalent fractions as 1, the square root of 3, and 2. And then again, I am going to fill in what's actually in my triangle here. And how I remember these is I remember 1, 2, and 3 are involved, but they're not in order. That's usually what I remember. So you got to kind of figure out your things. How do you remember stuff? All right, so let's do an example here. Solve for x and y and rationalize the denominator if necessary. So again, I'm going to set up a table. So I'm setting up 30, 60, 90, and I know the ratio is 1, square root of 3, and 2. And then I want to put what's in my triangle. So what's across from 30 is y. What's across from 60 is x. And what's across from 90 is 6 times the square root of 3. So these are equivalent fractions. So I want to set 2 together and solve for a variable. So clearly I need to use the fraction under the 90 degrees because I only want to have one variable. So I have to use 90 first. So to set up for solving for x, it doesn't matter which one, but I'm going to say the square root of 3 over x equals 2 times 6, the square root of 3. So I'm going to cross multiply. So I have 2x equals 6 times the square root of 3 times the square root of 3, which we just reviewed is the square root of a number times the square root of a number is that number. So this is going to be 2x equals 6 times 3, which is 18. Divide both sides by 2 and I get x equals 9. So I get x is 9. And then to solve for y. Now, I personally, you could use any two fractions now, but I always use the given information because if I made a mistake, I'm going to just make another mistake. So I actually always try and use the given information whenever I can. So I'm going to say 1 over y equals 2 divided by 6 times the square root of 3. So again, I am cross multiplying because I have equivalent fractions. So 2y equals 6 times the square root of 3. Divide both sides by 3 and I get y equals, or divide both sides by 2, I get y equals 3 times the square root of 3. Okay, so for an exit ticket, what I want you to do to get ready for our next lesson is I want you to tell me what the sides of the triangle are. If I have a 45, 45, 90 and a 30, 60, 90, and I'm defining that across from 90, the hypotenuse is 1. I want you to tell me what the actual side values are for the other triangles. So please have that done before the next lesson.